We'll use an I suffix for this new layer of curly. So we have class I's, which in addition to field names and methods as before, now have a supername symbol. And of course we'll pair a class I with a symbol to represent the full class declaration. And our XBys are almost the same as exps, but instead of sends, we have a super I instead. So super I just has a method name and an argument expression. It doesn't name any class, and it doesn't have a this expression because it's implicitly sending to this. To interp XBys, we will need to convert them to exp, the core interpreter exp. And so we're going to do that with a compiler function xby to c, that is, change an xby down to the core grammar of expressions. And for some expressions, it's very easy. So a num I just changes into a num e by this compiler. Or a this I turns into a this e, plus I turns into plus e, and so on. More interesting one is super I, that needs to turn into send e. And an send needs an object expression, but super always goes to this, so we can drop a this in. And it's still the method name, and it's the compiled version of the argument expression. But in super I, we need to specify the name of the superclass. And we don't have that information right now in this call to xby to c. So we have to adjust xby to c, and we're going to change it to take an expression and the name of the superclass for wherever we're compiling. And that way, when xby to c encounters a super I, then it has a superclass name given to it, and so it can know to use that as the class for the static send. So here's what xby to c looks like. We have our expression, we have our super name. Again, often when we recur, when xby c calls itself, it passes along the same super name. So let's make ourselves a recur function here. Num I is compiled to numies, plus I compiled to plusies, where we recur in the sub-expressions. Super I turns into send, send, a static send, with this e, and it uses that super name that's provided by the caller. Keeps the same method name and recurs on the argument expression. Converting the expressions is part of the picture. We need to convert classes that have expressions in them in their methods. So we start with a class I to c not flat. And the not flat part here means we're just converting the xbys to exps without trying to merge fields and merge methods yet. So all class I to c has to do is forget about the super name, except use that while you're compiling each body. So we're converting a class I to class C, keep all the same field names, map over the methods, keep the method name, and in the method expression, which is the second part of the tuple, compile it from an I to a C using that super class name that we had in the class I. But then we can forget it afterwards in class C. That is converting a class I to a class C, but it doesn't merge the field names and method names yet. So Flatten class is going to take that job. It's going to, you give it a name of a class that you want to flatten. You give it a list of class C's that are, named class C's, and then you give it the original class I declarations. So its job is going to turn one of these class C's into a class C with the extra methods and fields. So what it does first is it finds the classes that we're interested in, the class that we've been asked to convert by Flatten class. And we got a class C with the immediate field names and the methods. Now we want to merge in the ones from the superclass. So to do that, we flatten out the superclass. And that takes care of the recursive flattening. So maybe the superclass has a superclass and so on. We'll write the flatten super method in a minute. But what you do for flatten super is you pass the name of the class whose superclass you want to flatten and give it the same list of class declarations that we have here. So let's suppose we get a flattened superclass back. We can do a type case on that and get the superclass's field names and the superclass's methods all flattened out now. So that means the total fields for our new class are these field names added to that field names. So we're going to make a class C where we add the fields together. In fact, we'll just define add fields to be append, because that's all we need to do to add these field names together. But for methods, it's a little more complicated. So we'll have an add replace methods function that takes the superclass methods and adds these new methods. If there's a method here that doesn't exist in the superclass list, then it'll just be added. But if it exists in the superclass one of the ones here should replace it. That's a pretty straightforward function over lists, so we'll set that aside for now and talk about flattened super. So flatten super gets the name of the class whose superclass we want to flatten out. So that means we need to find the I class for name, because that's where its superclass is stored. And we pull that apart with type case so that we can get this superclass name. This is the name that we want to flatten now. So of course that's just flatten class on the superclass name. But there's a catch. That superclass name might be object, the built-in class. And since it's built in, it doesn't have any declaration in these other two lists. So we need to double check whether supername is object, and if it is, in that case, just return a class with no fields and no methods. And then the right thing will happen when those empty list of fields and empty list of methods are merged with another class. The interpreter for interp_i then needs to do these transformations and then chain to the interp for our core class language. So these transformations are to take the main expression for our program with inheritance and convert that main expression. We use object as a dummy superclass name because there should not be any supercalls in your main expression. We do the class I to class C conversion without worrying about flattening fields and methods, and then we go back over those classes that are converted but not yet flattened, and we use flatten class on all of them. And to do that, we take the name of each pair and pass that into flatten class and then recombine it as a tuple so that now we have a list of core classes that's derived from our list of class I's that came in. Since we've converted both the A, the main expression, and the classes, then we can call interp with our dummy object and dummy value, and the program will be interpreted.